Hi, my name is Paramesh Rao and my lab partner is Siti Sara binti Azrin. We carried out an experiment named Characteristic Curves of Semiconductor Diodes and we are going to present about it. The objectives of the experiment we carried out was to study the properties of semiconductors and to determine the characteristic curves of semiconductor diodes. So before we go further into the experiment details, let's dive into the theory and understand more about what semiconductor is all about. So in a solid, there's two bands known as valence band and conduction band, and the band which contains electrons is known as valence band and the one is empty is conduction band. And these two bands are actually separated with a forbidden region where the electrons are not supposed to stay in that. So in a conductor, the valence band is partially filled, and so when an electric field is applied, a current is established. But in an insulator, the valence band is completely filled and there is a huge band gap there, which means there is no way for the electron to pass through that band gap because the band gap is the forbidden region where the electrons theoretically cannot be stayed. However, in semiconductor, there is a band gap between the valence band and conduction band, but it's small enough for the electrons in the valence bands to jump. So with this, the current is actually established. With band model for solids, we can understand what exactly is happening with the electrons' movements of the semiconductor. And semiconductor devices are actually very important and very useful because the resistivity of the conductor can be controlled with the temperature. And how semiconductor is produced is that we actually just join the n-type material and the p-type material together, and that junction is called the p-n junction. And that junction, a drift current can be produced with certain conditions. And the semiconductor is actually non-conducting in reverse bias except for the Zener diode. So procedures. Throughout the experiment, we used few apparatus, and one of them is potentiometer, DC power supply, three diodes, namely 4000 series diodes, LED, and Zener diode. Other apparatus we used were milliammeter, voltmeter, and a bundle of connecting wires. So current passing through the diode by means of potentiometer was changed. The current is slowly increased until it reaches a saturation value. Current and voltage across diode is read for forward bias and reverse bias. At least 20 points were recorded, and the above steps were repeated for LED and Zener diode. The reverse bias was only done for reverse Zener diode.
Okay, for this slide and the next two slides, I will explain about data analysis. When we conduct the experiment, we use three different diodes, which is Zener diode, LED diode, and 4007 diode. The data obtained from this experiment for the Zener diode is when the current increases, the voltage will increase. When we plotted the graph, we can see that the voltage is increasing when the current is start to supply at 0.02. And the graph obtained is the curve graph. When we plotted the both graph, we can see the curved line on the graph. At current 0.02, the voltage is start increasing. For LED, the voltage start increasing at 1.602, while for 4007 diode, the voltage start increasing at 0.41. By using least squared method for 4007 diode, the gradient obtained is 24.87 and the y-intercept obtained is negative 13.96. So the linear equation obtained is y equals to mx plus c, with m is equal to 24.87 and c is equal to negative 13.96. So we construct the table as shown to find their uncertainty. The table was constructed to find the uncertainty of y-intercept and the uncertainty of gradient. And the graph above is graph ln I and versus voltage. From the formula, the uncertainty of m obtained is 0.52 and the uncertainty of y-intercept obtained is 0.27. So the result of the gradient and the y-intercept for 4007 diode is 24.87 plus minus 0.52, and for the y-intercept is negative 13.6 0.96 plus minus 0.27. By using the formula in equation 1 from the lab manual, we can get the value of n is equals to 1.65 plus minus 0.03. Goes to LED. If we need to find the gradient and the y-intercept, we need to plot graph ln I versus V. Okay, by using least squared method, the gradient that we get is 30.89 and the y-intercept that we get is negative 53.42. So the linear equation that we get is y equals to 30.89 x minus 53.42. So here is the graph ln I versus V that we plotted just now, and the next is the table that we construct to find the uncertainty of M and the uncertainty of C. Okay, from the formula, the uncertainty of the gradient is 0.62 and the uncertainty of y-intercept for LED is 1.09. So the gradient with the uncertainty for LED is 20.89 plus minus 0.62, and for the y-intercept is negative 53.42 plus minus 1.09. Okay, for LED in forward bias, we have the V0 is 1.602, so we need to find the N. By using formula in equation 1 in lab manual, we get the N is equals to 3.15 plus minus 0.09 as shown above. Okay. From the formula, the uncertainty of gradient for Zener diode is 0.55 and the uncertainty of y-intercept for Zener diode is 1.418. So the gradient of the graph is 38.62 plus minus 0.55 and the y-intercept is negative 27.95 plus minus 1.518. Okay, so here is the graph ln I versus voltage for Zener diode. Next is the graph that we construct to find the uncertainty of gradient and the uncertainty of y-intercept. From the formula, the uncertainty of gradient we get is 0.55 and the uncertainty of y-intercept we get is 1.418. So the gradient for graph Zener diode is 38.62 plus minus 0.55 and the y-intercept for the graph is negative 27.95 plus minus 1.418. For Zener diode in forward bias, V0 is 0.626 and from the equation 1 in lab manual, the N we get is 1.064 plus minus 0.015.
From the calculations stated by our Sarah, we can actually discuss and analyze a lot from the results. The IV curve graph was plotted for the LED, Zener diode and 4000 series diode. The saturated voltage for Zener diode and the 4000 series diode is 0.626 voltage and 0.410 voltage respectively, and it's close to the saturated voltage of silicon, which is 0.7 voltage. Silicon has a 0.7 electron volt of energy band gap between the conduction and the valence band. The saturated voltage for the red LED that we obtained was 1.602 voltage, and it's quite close to the exact saturated voltage of the red LED, which is 1.8 voltage. The red LED that made up of gallium doped with phosphorus and arsenic has a band gap energy of 1.8 electron volt that will emit red light. The material constant is obtained using LSM, least square method, to get the gradient of the ln IV graph and taking the logarithm of the equation 1 stated in the manual. The material constant for Zener diode, the 4000 series diode, the red LED is 1.064, 1.65 and 3.15 respectively. The Zener diode and diode 4000 have material constant that are close to the material constant for silicon. The red LED has a different value of material constant due to the different composition compared to the Zener diode and diode 4000. So in conclusion, the saturated voltage and the material constant for the Zener diode is 0.626 volt and 1.064, and the saturated voltage and the material constant for the diode 4000 series is 0.410 voltage and 1.65, and the saturated voltage and the material constant for the red LED is 1.602 voltage and 3.15. The references that we used. Thank you so much for your attention.